Welcome to Master X, the GMAT Guru, presenting you lesson number 8. Lesson 8, Quantitative Reasoning, Algebra 1. Overview. The Algebra Toolkit, Exponents, Format Time Frame, detailed examples are going to follow each section, and this lesson should take about 2 hours. Now, in fact, it won't take 2 hours because this is not the whole lesson number 8, but just a short version of it, so you can get a glimpse of what lesson 8 would look like by giving you some examples of what you are going to be taught in this lesson through the Algebra Toolkit and through the exponents part of the lesson. So it's just a short version of lesson 8. So the Algebra Toolkit, we're going to see one example from here, so you can see how you can solve an algebra type of problem in the quantitative section of GMAT. Combine like terms factor is the part of this lesson. And the problem is problem 5 from one of the many problems in the past from a GMAT exam, which states the following. What is the greatest prime factor of 12 factorial times 11 factorial plus 11 factorial times 10 factorial? Hope you do remember what a factorial is. If not, take one of my lessons and you'll find out. Now, and the answer is either A2, B7, C11, D19, or E23. Now, if you pay attention here, all of the answers are prime numbers. 2 is a prime number, 7 is a prime number, 11 is a prime number, 19 is a prime number, and 23 is a prime number. So they haven't given us an easy way out to be able to eliminate at least 1 and 2 of the possible 5 answer choices as immediately as wrong because they're not prime numbers, right? They've given us all prime numbers to choose from. So what is the greatest prime factor of all of this huge number? What do we do? Well, first of all, before I actually show you the tactic you have to use in order to solve this, quite fast, math-wise. However, you could use strategy number 1 also if you didn't have time or for whatever reason, your mind stopped and you didn't know what to do or you were stuck. You always have to remember strategy number 1 from our lesson number 1. Remember what a strategy number 1 states? You eliminate at least 3 out of the 5 possible answers if you can't eliminate 4 out of the 5, right? And then you choose between the 2 remaining one by following the rule C, D, B, A, E, right? Because that increases your probability of getting successfully the correct answer from 50 to about a 75%. All right, let's see if we can do that. Okay, first of all, since we want the greatest prime factor of this huge number, obviously that cannot be 2 or 7, because that's not the greatest prime factor. That's probably the least prime factor from the prime factors that exist inside this huge big number, right? So we can safely immediately eliminate A and B as possible correct answer choices. And now we're left with these 11, 19, or 23. Now, be careful here. Look at something. Here they give you 12 factorial times 11 factorial plus 11 factorial times 10 factorial as this big, huge number that it is, right? Now, the trap here that we're going to talk about later in a little bit more detail is that you can say, oh, there you go, so 11 should be the greatest prime factor. No, not necessarily. In fact, chances are, in a problem like this, if they give you something obvious like that, I mean the number that is appearing in front of your eyes, is definitely not going to be the answer that they're looking for. Why? Because they wouldn't have given it to you, right? Because that's not an easy problem. In fact, that's a difficult problem. All right, so when you see something like that in a problem in the quantitative section of GMAT, chances are the obvious answer choice is definitely not correct. So then eliminate C as the correct answer, because it's not, so 11 goes out, and you're left with only two choices, either D19 or E23. Now, without doing anything else math-wise, you can't actually choose between 19 and 23 for sure and identify which one you can eliminate, so you would be left with one. So then you have, using the strategy, number one, if you remember from our first lesson, choose between these two by following the order of choice that we talked about, C, D, B, A, E. So between D and E, you choose D as the correct answer. And that's it. Now let's see if we have actually chosen the correct answer using strategy number one by solving this problem now, combining like terms and factoring math-wise with the tactic that I'm going to show you. All right? So be patient. Let's see the next slide. This was the harder factoring, by the way, so yeah, it is a hard problem. So the steps we should take in order to solve this problem mathematically are the following. Step number one, start by factoring common terms. So remember the problem previously? It gave you 12 factorial times 11 factorial plus 11 factorial times 10 factorial. So obviously 11 factorial is a common term. So you factor that out as if it was a simple number, right? So you have 11 factorial times, in parentheses, 12 factorial plus 10 factorial. Easy, right? Now, for step number two, recognize the fact that 12 factorial is nothing more than 12 times 11 times 10 factorial. How do we know that? Well, remember, factorial means what? The product of every integer, including the one with the factorial sign in front of it, down to 1. So 12 factorial is 12 times 11 times 10 times 9 times 8 times 7 and so on down to 1. But 10 factorial is also 10 times 9 times 8 times 7 and so on down to 1. Therefore, 12 factorial includes 10 factorial in it. It's 12 times 11 times 10 factorial, which is the rest of the product of the integers. 9 times 8 times 7 down to 1. Alrighty? So that's an important thing to recognize immediately. So you can substitute this inside here in the parentheses. Now, step 3, continue factoring now because you have made another common factor appear by doing this, which is 10 factorial, which exists now here in place of 12 factorial, 12 times 11 times 10 factorial, plus 10 factorial inside the parentheses. So continue factoring inside the parentheses to get 11 factorial, which you already have outside here, times 10 factorial, common factor of this and this. So inside you're left with 12 times 11. You factored this out, remember, plus 1, which is for this, right? Because 1 times 10 factorial is 10 factorial. Alrighty? Simple factoring. Now, next step, step number 4. Now calculate the quantity inside the parentheses, alright, to get the number. So that'll give you 11 factorial times 10 factorial times 133. Now, remember, you don't have a calculator in GMAT. You don't have to do that by actually doing the multiplication by hand in your scratch paper that they're going to give you, 12 times 11 plus 1. Just remember, what's 11 squared? 11 times 11 is 121, which means that 12 times 11 should be just 121 plus 11, another 11, the 12th 11, right? So 121 plus 11 just gives you 132 plus 1, 133. That's the way you have to start thinking and doing math calculations in GMAT. Alrighty. Okay. Finally, step number 5, recognize the fact that the greatest prime factor of 133 is 19, right? Why? Since 133 is equal to 19 times 7. How am I going to recognize that, you're going to say? Well, first of all, you don't have to actually go ahead and factor this out in detail, prime factor it, right? Why? Because that would take some time and you don't have to do that. Remember, you have to choose from the numbers given to you, right? Let's go back to the previous slide so you can see again the possible 5 answer choices. All right, see here, you have to choose between 2, 7, 11, 19, and 23, and nothing more. So now you want to figure out what's the greatest prime factor of 133, basically, since you factored everything else out, right? The 11 factorial times 10 factorial times whatever is left inside the parentheses, which we just calculated was 133. Okay, now, obviously, It's not 2 times 7, right? It's not 7 times 11 because that's 77. It's either 7 times 19 or 7 times 23, but 7 times 19 is what? 7 times 9 is 63, so it ends in 3, the number. 7 times 23, 3 times 7, 21, ends in 1. You don't have to do any more calculations, that's it. The answer should be 7 times 19, right? Why? Because that's the only thing that gives you a number that ends in 3. That is 133 here. And that's all. So you found it. All right? So obviously now the greatest possible factor here, prime factor, should be 19. So the answer, thus, our answer choice is D. D is the correct answer choice. So we found it doing actually the math with this methodology, the 5 steps that I showed you right now, which is a way to do your math quickly without actually factoring out everything in detail. And also we found the answer before using strategy number 1, even faster, right? So you can choose between the two. If you have time, you can use the actual math and do it with this tactic. It'll save you time. It shouldn't take you more than 3 to 3.5 minutes maybe, max. All right, and if you get used to doing these things fast, it should take you about 2 to 2.5 minutes. But if you are in need of time, or you get stuck or anything, you could use strategy number 1, and then in just 1 minute max, you could have solved it correctly. Okay. All right. Now, remember, what did we learn here through this example? What does GMAT do for you? What do the examiners behind GMAT are trying to do to you, to test you on, right? To see if you're smart enough for them to accept you in the big institutions like Harvard and Yale, right? And MIT. They're selling the wrong answers to you, okay? Selling the wrong answers. 11, remember when we used strategy number 1, I told you that that was probably a trap? Well, indeed it is. In this type of problem, 11 is the obvious choice here, since it's the largest prime factor appearing in the problem, right? So then you have to ask yourself, what am I missing? Could it be so easy? The fact that there is addition in this particular case in this problem, and not only multiplication, is in the original problem. All right, 11 would be the greatest common factor only if it was a multiplication problem, but it wasn't. You had addition, remember? So you had to factor something common out of that. All right, so be careful, because they're always going to try to sell you the wrong answer. So don't fall for this easy trap. So you must factor first, in this case, to make it into a pure multiplication problem like we did through the tactic and the steps of the methodology that I showed you in order to actually solve it. Alrighty? Now let's see a couple of examples with exponents. With exponents, when the problem looks difficult, you just have to find patterns, that's all. Just look for patterns. Don't try to, calculate it by hand or something. So in this case, what's the problem? The problem is, what is the units digit of 2 to the power of 39? This huge number, another huge number here, right? So what's the units digit of 2 to the power of 39? Remember what a units digit is, right? The last digit of a big number, like 133, the units digit is 3. 1,224, the units digit would be 4. All right. So what's the units digit of this huge number? Is it 2? Is it 4? Is it 6? Is it 8? Or is it 9? Okay. How do we know? How do we calculate that? All right. Now here I'm not suggesting for you to do strategy number 1 because there are actually no common terms that can help you here eliminate some of the answer choices. But you should be able to solve it using the tactic that I'm going to show you. Now, remember that GMAT will never ask you to calculate such a massive value, but it will test whether you can predict what that number will look like, right? In fact, we have already done this before. We can establish a pattern, in this case, with exponents of 2 and extrapolate it up to 2 to the power of 39. So how do we do that? Easy, right? 2 to the power of 1 is 2. Then you multiply by 2 again to get 2 squared, which is 4, right? Then you multiply by 2 again to get 2 cubed, which is 8. These, by the way, you should remember when you go to GMAT by heart, right? Then you multiply by 2 again to get 2 to the power of 4, which is 16. Okay, you multiply by 2 again, 2 to the power of 5, 32. You multiply by 2 again, 2 to the power of 6, 64. Once again, you multiply by 2 to the power of 7, 128. And finally, 2 to the power of 8, 256. Now, hopefully by now, you have seen the pattern. What's the pattern? Look at that. It goes 2, 4, 8, 6, the last digit. 2, 4, 8, 6, the last digit. Let's see that again. 2, 4, 8, 6, the last digit. 2, 4, 8, 6, the last digit. So the powers of 2 recycle every 4 numbers. For every 4 numbers, the last digits of the powers of 2 recycle. All right? And they repeat themselves with this pattern always. 2, 4, 8, 6, 2, 4, 8, 6, 2, 4, 8, 6. So once you do remember that, then you know that all the multiples of the powers of 4 will give you a big, huge number that ends in 6. All the multiples of the powers of 3 will give you a number that ends in 8. All the multiples of the power of 2 will give you a number that ends in 4. And all the multiples of the power of 1 will give you a number that ends in 2, and so on. All right, that's all. So what do we do in this case? The solution is the following. Every 4th digit, as we just said, is a 6. So in this case, 2 to the power of 40 will end in 6. Why? Because 40 is just a multiple of 4, right? 4 times 10 is 40. So that also should end in 6, that huge number to the power of 40. So 2 to the power of 39, which is the number we're looking for in this particular problem, is just one number prior to 2 to the power of 40. So one number prior in this cycle. So before 6 is what? 8. Remember the pattern was 2, 4, 6, 8. 2, 4, 6, 8. So before 8, 6. Right? Before 6, sorry, 8. 2, 4, 8, 6. So 2 to the power of 39 is just one prior in the cycle. So it should end in 8. Right? So the answer choice is D. And that's all. You found it. Okay. So remember, it's all about patterns, finding patterns. So the guiding principle on this type of problem, big exponents, do not be intimidated by large numbers in GMAT, and especially by large numbers with exponents. All right? Find patterns. Always find patterns. You can find patterns like I just showed you. Once you do that, you'll be done like that immediately. All right? Now let's look at the next difficult exponent type of problem. All right, you have this problem. It states if x equals 5 to the power of 25 and x to the power of x is equal to 5 to the power of k, what is k? Just looking at it, you're like, wow, man, what's that? How am I going to solve this? Well, just relax. Let's look at the possible answers first. A, is it 5 to the power of 26? Is it 5 to the power of 27? Remember, this is supposed to be k, not the whole number, just k. Okay? So the whole number would be 5 to the power of 5 to the power of 26. We're looking for k here. That's the question. What is k? So is k 5 to the power of 26, 5 to the power of 27, 5 to the power of 50, 5 to the power of 52, or 5 to the power of 625? All right, so remember again, the question is, what is k? This one, not including the base. All right, so if k was this is the correct answer. That means the answer here is 5 to the power of 5 to the power of 26. Okay. Now, by the way, since they give us here that x equals 5 to the power of 25, that means we can substitute that in the place of x. So here we're going to have 5 to the power of 25 and all to 5 to the power of 25, right? Boo, big, huge number. Now, before I actually show you how to solve this quickly math-wise again, so the tactic, let's go back to the strategy. Remember strategy 1? Just in case you get stuck, you don't have any more time for this particular problem, you want to do it very, very quickly, right? Or you get stuck and you don't know what to do, right? Mathematically speaking or tactically speaking. Then again, you can use strategy number 1 in these types of cases. How? Well, let's see. Keeping this in mind that this is 5 to the power of 25, which is substituted in here, okay, and we're looking for 5 to the power of k, what could, and they don't have the same base, 5 to the power of 25, right, which means that in order to make it equal, you will have to tweak it a little bit if you had the time to do the math. And here again, you have 5 to the power of 25. What could k be? Or let's go the opposite way, process of elimination. What should K, shouldn't be, right? Okay, let's go with the big numbers. Could K be 5 to the power of 625? No, that's huge. How you could get that out of this? That's impossible. So you immediately eliminate that. Now, careful. Could K be 5 to the power of 50? Well, again, that's an easy trick or an easy trap to fall into. Why? Because here they give you 5 to the 25, so you can say, if you're trying to do it quickly, oh, this is 5 to the 25 to the power of 5 to the 25, so I'm going to just say 25 plus 25, 50, right? Nah, they thought of that when they made that problem. That's why they gave you this answer, to trick you. All right? So don't get tricked. Don't fall into the trap. So definitely it's not 50. Why? Because that's what a lazy person or a person who got stuck would do. Would say, yeah, 25 plus 25, it's 50. So definitely C is not the correct answer. And E is not the correct answer, we said before, because it's huge. So obviously D shouldn't be the correct answer either, which is something in the middle, 5 to the power of 52. So we eliminate immediately C, D, and E, and we're left with A or B. Now here, without doing anything more math-wise, we cannot actually eliminate any one of the two as definitely wrong, so we would have to choose randomly between A and B for the correct one. But remember, you don't just choose randomly, you choose when you're left with two possible answers, you choose by following the process C, D, B, A, or E, because when you choose like that, with that order, then you increase your probability of success from 50% up to at least 75%. Alrighty? So between A and B, you choose B and you move on. Now let's see if you're using strategy number 1, process of elimination, and then when we're down to two possible answers, choosing with C, D, B, A, E, so in this case between A and B, B, if we are correct again, like before or not. So let's go and solve it math-wise by using the following tactic. All right, now problem number 11 is an example of how problems are made hard through the use of large, difficult numbers, seemingly, right? They try to scare you in GMAT. The first step with this problem is to substitute, as we said before, in the place of x and get the following equation. So you do that in your scratch paper that they give you, right? So 5 to the power of 25, all of that to the power of 5 to the 25 equals 5 to the k. All right, you have that in front of you now. How do you solve that? Again, don't get confused by this huge number, all right? So important to know the basic exponent rules deeply in order to solve this, right? So if you were given the following, again, know the basic exponent rules deeply. If you were given the following, what would k be? 5 to the power of a, all of that to the power of b is equal to 5 to the k. What would the answer be for k here now, right? It's easy, right? Think about it. Say it aloud before I move on to the next slide and let's see if you got it correctly. So 5 to the power of a and all to the power of b is equal to 5 to the k. What should k be? It should be a times b, right? It's pretty clear for most of you, for most students, that k in this case would be equal to a times b, because that's what you do. You multiply exponents in this case. Now extrapolate that to understand what to do in this example. In this equation that we have here above, a is 25, because it's 5 to the power of 25, right? 5 is the base. And b is 5 to the power of 25, the other exponent. So we have k equals 25, which is a, times 5 to the power of 25, which is b, or 5 squared, which is 25, times 5 to the power of 25. And now remember your exponent rules. When you multiply bases, you add exponents, if the base is the same, of course. So 25 plus 2, 27. So the answer is 5 to the power of 27. So k should be 27. So answer choice B is correct. And remember what we found before when we used strategy number 1 with the process of elimination? Again, we found B. There you go. So if you just follow the strategies and the tactics that I'm teaching you, you're going to do excellent in GMAT. All right, so you have to be able to find difficult patterns in GMAT with big numbers. Abstraction and large, awkward numbers is what they're going to try to give you in order to trap you, in order to trick you. So what is the really big takeaway from both of these problems, the examples that we just saw? Exponent problems only really get hard when test makers employ abstraction using x's, variables, and or large difficult numbers, like the 2 to the power of 39, right? If you are solid with exponent rules, you know them very well inside out, and you use simple examples to remove abstraction, like with the x before, or show patterns to yourself, right? Write them down, see the pattern, like with the 2 to the power of 39, the 2 to the power of 40 should be a number ending in 8, right? You will succeed on any GMAT exponent problem, always. So you don't have to memorize these examples that I'm showing you, because you can have thousands of similar examples, and the problems on GMAT always change in every GMAT exam a little bit. All right? But you do have to know your exponent rules very well inside out, and also learn, this trick that I've just showed you, or this takeaway, or this advice, whatever you want to call it. Meaning that don't be afraid when you see big, huge numbers or abstractions. If there's an abstraction with an x or a variable or a y or whatever else, put a number in it to try to make it easy. Or if it's a huge number like 2 to the power of 39, find the pattern, right? That's all. So this is the end of lesson 8. See you in the next lesson, my friend. So, this was lesson number 8 offered to you by Master X, the GMAT guru. So if you liked what you saw and you want to be able to solve GMAT problems like that and to prepare yourself for the GMAT examination so you can be accepted to the most prestigious schools all over the world, then do not hesitate. Call me in Skype now. Find me with my handle ZARKX and make an appointment for a free consultation call. Right? So find me with my handle ZARKX and make an appointment for a free consultation call where we can find out what your needs are, and if I can help you prepare for the GMAT exam. And if I can through one of my GMAT courses or with my GMAT workshop, then do not forget the first lesson is always going to be free, and all the material, the preparation material that I'm going to give you is also going to be free. So don't hesitate. Call me in Skype right now. Find me with the handle ZARKX and make an appointment for a free consultation call. Don't forget, my name is Kyriakos Xafis. I'm the former Director of Studies at Access Revenue Economics